So before I talk about defining a model, I just want to give a high-level perspective on how you're going to access the CS2 within the ALCF AI testbed. Now, Bill is going to cover this in much more detail coming up, but I think it's a little bit of necessary context, so we don't just jump in too much. So as we look at these steps, 1 through 6 on the top left, please try to orient yourself down to the bottom left. So this is comes straight out of the ALCF documentation for Cerebrus. But at a high level, you're going to request an account if you haven't already through ALCF. That account is then associated with the Cerebrus project. I know I've seen some mentions of this from existing users. You'll be given an account, the secure means of access. That's all handled through ANL, ALCF. And in that way, you'll be able to log into one of the ALCF login nodes that can communicate with the management node in the Cerebrus cluster. From there, the experience is totally the same as if you would access a CS2 in any other way, pending the version of the software that's running at ANL. So that looks much more like what we see in the bottom right of your screen. So you're going to create a virtual environment. The wheels are already there for some of our software. You can clone Model Zoo, our public collection of our model implementations, and the foundation for the kind of YAML and run script workflow that we have. And then you can use those existing implementations or make it your own. So if you look at this diagram at the bottom right, you'll see the login node of ALCF is the same as any other Cerebrus user node. You define your models, change configs, run away. But the appliance itself, everything within that kind of dotted line, that square, is abstracted away from you. So you'll submit jobs to the Kubernetes based system for job submission and queuing. And from there, you can use our utilities. And Bill sees that I have a typo in my slide. So thanks for calling that out, Bill. And I'm sure you'll get us fixed in just a few moments. So next. So the basis for your initial work with the CS2, and potentially much of your work, depending on the use case, will be the Cerebrus Model Zoo. Now, this is a public code repository. You could go to that link in orange right now and go check it out. You'll clone it from GitHub, use it with any pip install packages you might have on the user node. And our typical process involves users starting from the Model Zoo and then modifying the models and data loaders that they use, depending on their workloads. So what that Model Zoo provides, you could use it as a starting point. We have reference PyTorch implementations of various models and architectures so that you can start training from scratch right away. We provide configurations for multiple model sizes, from tens of millions of parameters all the way up to many billions. So you don't necessarily need to reconfigure it, especially if it's a popular model and a popular size. Next, we also provide data preparation scripts, right? And we know everyone wants to train models and fewer people want to spend their time working on the data. So we try to provide help with that too. We also share some of our open source work on Slim Pajama, which we've used and extensively deduplicated a trillion tokens data set. So Model Zoo is also a way that we take some of our learnings and expose those and that knowledge to our users. Those scripts are available. And we offer different data loaders to meet your needs. You can also use the Model Zoo for benchmarking. We offer tuned implementations for higher performance. And if you want to find us in the ANL Cerebrus Slack, we can certainly even go deeper and see if there's more performance to be gained. And then once you become a pro at using the CS2 and you kind of master these flows, you have the flexibility to go deeper, to develop your own models. And you can do that using our Layers API, our PyTorch APIs, or the templates we provide, whatever level of abstraction is appropriate. And I really want to foot stomp that Model Zoo is a tool. It's not necessarily a lock-in mechanism. So you can use our reference models to start training from scratch immediately. Some others prefer to take a pre-trained model checkpoint from, say, the Hugging Face ecosystem and continue training from that, or use that as a comparison. You'll be able to convert your models into the Cerebrus format as well as back out, so you're certainly not locked in to the system. Take advantage for the training and take the models where you need to. And then you can use, of course, the APIs. For all of this, we have public documentation at docs.cerebrus.net, and that accompanies the Model Zoo. That kind of walks through the capabilities via short how-to guides, also just traditional documentation of how our APIs are built, and also provides longer end-to-end tutorials that you can kind of take bits and pieces of and adapt them to your workflows. And in that way, you can use the Model Zoo to its fullest effect. So no matter how you want to use the CS2, we want to help you experiment faster. So the typical anatomy of a model in Model Zoo looks a lot like this. Right? There's a run script meant to execute the training and evaluation loops. We'll have various configurations, so a directory with different parameterizations of the models and YAML files, whether it's at 7, 13, 33 billion, whatever you need there to help you get started faster. The model script will create a neural network model. The utils provide helper functions to set up the run, and then data, we provide helper functions there. So if we go a level deeper into run.py, it's just kind of your one common script to compile, to train, and to evaluate. This instantiates the CS estimator, creates the run config to be passed the estimator, and calls kind of the appropriate functions, train and evaluate, based on the mode passed by the user. So the two most common modes are train or eval. We also offer an eval all functionality. So if you want to evaluate a directory full of model checkpoints, you can easily do so. You don't have to write necessarily a loop for that. And then we supply an interface, to run your models with this. Now, you'll also, if you want to move outside of this with our PyTorch API, that's in beta right now and will be continues to be, I think, fleshed out and used across. You'll have even more flexibility to go lower, write your own training loops. It's not necessarily that these options aren't available to you right now, just through a different mechanism. And then finally, we have additional flags if you want to just validate only kind of compilation up to the point of kernel matching. Good to check that your code is compatible with the CS2, or compile only. So you can run it end to end, generate an executable, and use that to pre-compile jobs for CS systems. And so we kind of imagine this user flow, or at least have seen that this workflow kind of exists in a few stages. And the big takeaway here is that you'll be able to look to the left, orienting on the chart. So you have different levels of granularity accessible, from data processing and data loaders that are straight out of the Model Zoo, to models straight out of the Model Zoo, all the way to fully custom data processing, full flexibility, the PyTorch API. So a lot of information here, but to orient, stage is the level of customizability you desire. That center column is kind of how you're going to go about that data processing, data loading. And the right column, the model architecture, is how your method to define your desired model. So step one, kind of first row, if you're getting started with the Cerebrus ecosystem, if you're using one of our Hello World tutorials, then we recommend using the data processing and data loaders that are available straight out of Model Zoo. We offer these optimized data loaders that work with standard formats and public data sets that you may want to bring in. Maybe it's not a data set, or it is one that's commonly used, but maybe not common to us. And then you can use our model references, use those YAML files, kind of get oriented to our system. Then you can customize that YAML, dropping in, let's say, a different positional embedding, changing the width of the model, working within that framework. As you want to use your own data, you can move down to row 2. So here you kind of maintain what you were doing in this first stage, working out of the YAMLs from the model side, that model customization. But then we allow you to write your own data loaders. So we have guidelines on how to get you the best performance. And in this way, you don't want the data loader to become the bottleneck because the system is so fast. And again, if you ever feel that our documentation isn't getting you all the way to where you want, please do reach out. We want that feedback. We want to make it more clear, and we want to find the best way to empower you. Row 3 is defining your own model using the Model Zoo tools. So just as you would customize your data loader in stage 2, you would do it here in stage 3. But now you can use our PyTorch runners, our layers APIs to stitch together your own model. And then finally, if you want the most flexibility, you want to feel the same as just writing the model out in PyTorch, defining your data loaders, defining your model, your loss functions, your optimizers, right at your training loop, we provide that option, that level of granularity as well. Okay, so the next few slides just kind of reiterate these points. I won't ask you to try to squint your eyes and read the code blocks on them, but I think there will certainly be opportunities on day 2 to go a little bit deeper. But please do check out our model zoo, check out our documentation if you want to see this a little bit more in action. So if you were in that phase 1, that stage 1 of just getting started, you can hop right into the model zoo, get onto a CS2, clone the model zoo down, and then just follow the READMEs, follow the tutorials right there, not really changing much out of the box. We have a question says missing, where is the model zoo? The model zoo is just publicly located on GitHub. So that orange link at the bottom. So next, that stage 2, you want to modify reference models. If your primary goal is to use one of these architectures with some minimal changes, we recommend making those pretty minimal changes within the existing model zoo structure. So a scenario might be working with FCMNIST. In this case, we'll show building a synthetic data loader to evaluate network performance. Want to change kind of randomly just input sizes, number of classes. Now to achieve that goal above, we'll in the data.py, we'll create a function called getRandomDataLoader. We'll create the images, and then we'll point to our params file to ensure that we're actually pulling those params out, the image size, the number of classes. All right, so here in data.py, we create that function. It's probably too small to see on many of your screens right now. Oh, thank you for sharing the model zoo repo in the chat. And that function is going to create our random images, create our random labels. We'll then, in the model file, change the number of classes to pull from the parameters file, that configuration YAML. And then in that associated YAML, within the data loader sections, the train input, the eval input, we'll add number of examples, batch size, seed, anything else you need to pull from there. Within the model section, the model will be looking for input size and num classes. So your run workflow is essentially the same, right? It feels no different. You're making small changes within the YAML. Now, that's not necessarily for everyone, but I think is a good place to start. So if you want to create new models leveraging the Cerebrus run function, we think you should or recommend using kind of the common backbone within the model zoo. So the run function, just like in PyTorch, kind of modularizes the model implementation from the data loader implementation and then the execution. So to use that function, you need to define these things separately and then leverage your params YAML file at runtime. Right? So you'll define your model, define your data loader, just like you would in PyTorch, just like you would on a CPU, on a GPU. This is not anything Cerebrus specific. And you kind of can break it down step by step, build out that training loop calling run.py. So nothing should feel inherently so different than what you would do with PyTorch. And now, kind of option 3 is going even deeper into this YAML file. So we've shown the train input, the eval input, the model, but there are actually other sections. And again, I recommend going into and exploring some of this code in the model zoo, and we'll certainly do it tomorrow. You have to have the run config and the optimizer sections that are going to help you define your optimizer type, learning rate, scaling factors, as well as how long your run is, how and when you're going to take checkpoint steps, how and when you're going to log. So these are all come together in a pretty well-defined way. And then finally, up until now, the workflow has been primarily based around those PyTorch runners. that has created, some minor limitations. It's more tied to Model Zoo. Um, it is great that it's easy to configure, but some people just want more customizability. And we want to make sure that we offer that as well and meet you wherever you're at. So with this new PyTorch API, we're making things as transparent as possible. We'll give users the flexibility to write their own training loops, and really should be able to give you as much control at a low level as possible. And I think if you want to dive in more specifically to that, there are some great deeper dives here in our documentation. Again, docs.cerebrus.net is where you're going to want to go for that. And with this, like, here's a simple sample of a full training script. Again, this is entirely available in the docs. I wouldn't hurt your eyes squinting at the code. But we bring in kind of every piece that you would just as if you were training with Torch. And then you have greater control now with context managers. So things that were added recently in PyTorch 2.0, we will support as well. So greater control of that training step when you try to take checkpoints, custom checkpoints, accessing tensors, custom formats. So fully customizable your training needs if you need it, and only when you need it. And you can do all of these things today, but it just gives you another lever to have more control. And so when we think back to what the system is offering, we offer performance through the appliance, we offer access for open science through ALCF as well as other means. We try to meet you at whatever level of usability you desire. So you can scale out to more systems, you can scale up to more parameters, you can keep it simple through our higher level workflows, or you can get into the weeds. And we hope that that has created an ecosystem, really, where we can help you accelerate what you want to accelerate and abstract away the things you don't want.